Hello, you are highly welcome to another exciting edition of Mathematics Being Made Easy. The previous days we started looking at the trigonometric identities, or the trigonometric ratios, and we got to know how the ratios came about. So for today we want to look at the identities. We want to also get to know how the various identities came about. And I believe that you'll be able to enjoy this lesson. So kindly sit put and enjoy the lesson. If you have any difficulties, I would entreat you to pause the video or slow the speed. Then you watch it critically so that you'll be able to get every nitty-gritty from this particular video. Thank you very much. Let's now dive into the lesson. So we want to get the various identities. So before we get to the identities, a diagram will help us get the concept clearer. I believe everybody knows about the Cartesian plane. The Cartesian plane. This is our what? Our y-axis. Our y-axis. Then we have our x-axis. Our x-axis. This is it. Then we will draw a circle. So let's now draw the circle. So this is my circle. This is my circle. So mind you, it's not drawn to scale. It's not drawn to scale. So taking the meeting point of the two lines into consideration. So let's consider it as the center. So this is the center. So from our area of a triangle and then the perimeter, so area of a circle and then the what? The circumference of a circle. We know that every line moving from the center of a circle to any part of the circumference, or any line moving from the center and that particular line touches any part of the circle, we refer to that line as the radius. So this is the line moving from center to the circumference. So we refer to it as what? The radius. So likewise, a line can move from here to this part. It's the same radius. From here to this part, it's the same radius. From here to this side, it's also the same radius. Mind you, the diagram is not drawn toward scale. Then, if that is the radius, we can complete it to get a right angle triangle. So moving from here to this place, we have our 90 degrees here. 90 degrees, giving us what? A right angle triangle. You know that this line is the y-axis. So the line from here to this moving upward, we refer to it as our y. Then the line from what? You can see there's another line which is our x-axis. So this becomes our x-axis. Now let's introduce theta, our angle. So let's assume this is where our angle is. Theta. Theta. So that is our angle theta. So you will realize that if it is like this, so this is what we are currently having. If I remove the diagram from the figure I've drawn, or if I get the right angle triangle from the figure I've drawn, this is what I have. I have something like this as my right angle triangle with my 90 degrees here, and my angle theta is here. My angle theta is here. So this is my x, this is my y, and this is my r. So with this, we will be able to find out the various identities as far as the trigonometry is concerned. Now, Pythagoras also said something. Pythagoras said that the square of the radius, or which we call the hypotenuse square, is equal to the sum of the opposites, which is what? We have x squared plus the y squared. So that is what Pythagoras said. Pythagoras said that what? The sum of the square of what? The hypotenuse is equal to the sum of the square of the opposites and then the square of what? The adjacent. So that is what he said. Now with this we can equally deduce the trigonometric ratios from here. So let's move to the other side so that we get the trigonometric ratios. So sine. We looked at the trigonometric ratios, the sine, the cos, the theta. So sine, we know that what? From the diagram, we know that our sine is equal to what? When the angle is facing is the opposite. So our sine becomes what? Y, which is what? The opposite. Y over the r, which is our hypotenuse. So our sine is equal to y over the hypotenuse, which is r. Then our cos, which is cosine, will be equal to what? This is where it is lying on. So adjacent over hypotenuse. If you still don't know about all the trigonometric ratios, kindly watch the video that I made with respect to that. You surely get it there. So our cos is what? The x over r. And then our tan theta, which is the tangent, is equal to what? Opposite over adjacent. So opposite, the opposite is y, and the adjacent is x. So with this, we will be able to get all the identities. With this, we will be able to get all the identities that we need. So moving to the Pythagorean theorem, the formula that he brought into being, which is r squared. Let me use it the other way around. S squared plus y squared is equal to r squared. Now, let's divide the whole of this equation with r squared. So we have x squared over r squared plus y squared over r squared is equal to r squared over r squared. I hope you are following. This can equally be written as x over r all squared plus y over r all squared. You know that when r squared divides r squared, we'll surely get 1. So this one is nothing but 1. Now, this is what we have. Check as to whether we have something here that is in this form. When you take x over r into consideration, let's check which of the trigonometric ratios has that. X over y. The x over r, you can see that when we check s over r, this is it, it's cos. So in place of the s over r, let's put cos there. So cos theta squared, representing s over r, plus all squared, so this is the square. Then we have y over r. When we check, we have y over r, which is sine theta. So sine theta all squared is equal to 1. I hope you are following. So cos theta squared, this as what? Cos squared theta plus sine theta squared, this as what? Sine squared theta, which is equal to 1. So this becomes an identity. This becomes what? An identity. The first identity, which is what? Cos squared plus sine squared is equal to 1. So you will see how we've been able to use the diagram to come about with this cos squared plus the sine squared, giving us what? 1. We can equally say that we can make cos the subject, we can make sine the subject here to get other sub-identities. So for instance, if we make cos the subject here, we'll have cos squared theta is equal to what? 1 minus sine squared theta. This is equally a mini identity. Then we can equally have what? Sine squared theta giving us what? 1 minus cos squared theta. I believe you are getting the point. So this is just one of the identities that we have. You will see how easy it is. We've been proving it slowly, moving from one stage to another. I hope you are getting the point. Let's move forward by proving for other identities. So, with the same x squared plus y squared is equal to r squared. Now let's divide through by y. Let's divide through by y. So x squared over y squared plus y squared over y squared is equal to r squared over y squared. Are you getting the point? Good. X squared over y squared, we can equally write this thing as x over y all squared plus what? Y squared divided by y squared gives us 1. It just produces 1. Nothing but 1. And we have what? R squared over y squared. Are we getting the point? Are we getting the point? Good. So let's check as to whether we have any x over y squared. From the diagram, we don't have x over y, but we have what? Y over x. So it means that what we have here is the inverse of that. This is the inverse of that. So this can be written as what? 1 over tan theta all squared plus 1 is equal to r over y all squared. Do we have any r over y there? We don't have r over y, but we have y over r. We have y over r. So that is telling us that it is an inverse of what we have here. So the inverse is what? 1 over sine theta all squared. Are we following? Very easy. So this alone, what would it give us? This, from basic trigonometry, we know that this is 1 divided by 1, 1 over 1, or just 1 divided by tan theta. We know that tan theta is the same as sine theta over cos theta. Then, with multiplication of fractions, we can reciprocate. So this gives us 1 times cos theta over sine theta, which is the same as cos theta over sine theta. So 1 over tan theta is just the same as cos theta over sine theta. So let me clean this, because that one is a rough work. So here we have what? Cos theta over sine theta plus what? 1 is equal to 1 over sine. 1 over sine is nothing but, this is squared. 1 over sine is nothing but, we call it what? The cosecant, which is cosec theta all squared. So this gives us cotangent, which we call cot theta all squared plus 1 is equal to cosec theta all squared. So when we open the brackets, this is what we are going to have. We'll have cot squared theta plus 1 is equal to cosec squared theta. So this becomes another identity. This is also another identity. So from here we can say that we can make cot the subject. So cot squared theta is equal to cosec squared theta minus 1. Or we can equally what? We can equally say that what? Cot, or we can say that what? 1 is equal to cosec squared theta minus cot squared theta. Or finally, we can also say that what? I think this is it. So 1 is equal to cosec squared theta minus what? Cot squared theta. So that is the second identity. Now the last but not least identity, let's divide through by x. Let's divide through by x. Okay, so we are now dividing through by x. So this is what we do. X squared over x squared plus y squared over x squared is equal to r squared over s squared. Now this is nothing but 1. This is 1. And this can be written as y over x all squared is equal to what? R over x all squared. So this is 1 plus. Do we have any y over x? Yes, we have y over x. When you check, we have y over x, which is what we call tan. So in place of this, we put tan theta all squared. Do we have any x, any r over x? No, we don't have any r over x, but we have x over r. So it means that this is the inverse of that. So we have 1 over cos theta all squared. So 1 plus tan theta all squared is equal to 1 over cos theta all squared. 1 over cos theta is nothing but sec squared theta, which is secant squared theta. So when we open, we have what? 1 plus tan squared theta is equal to what? Sec squared theta. So this is also the third identity. From this identity, we can equally say that tan squared theta is equal to sec squared theta minus 1. Then we can also say that sec squared theta minus tan squared theta is equal to 1. I believe you are getting the point. Thank you so much for watching the video. I believe it has helped a lot. Those of us having problem with this trigonometric identities and issue, I believe this video will do a lot of good to us. I kindly want you or entreat you all to kindly subscribe to the YouTube channel so that I'll continue to record more mathematical contents for you. And also those who are on TikTok, my page is there. Go to it, continue to follow, like, share the video. Let it go viral. Who knows, it might help your sister somewhere, it might help your brother somewhere. Thank you very much for today's tutorial.